Hi, this is Mr. Max with Sankofa Mathematics. I am doing paper 2 of 2019 extended. The content is also valid for learners in grade 10 to 11 following the new syllabus. You can use this, print out the copy of the question paper that I have loaded up on the Google Classroom. Towards the end of the video, you are going to see a slide that has got all the details of how you can join any one of my classes where I have information, material, videos that I have loaded up. The codes, you just join the classes. Firstly, I just want to briefly explain what is the meaning of Sankofa. Um, well, it's an Akon word. That means we must go back and reclaim our past so that we can move forward. So we understand why and how we come or came to be who we are today. The word also means it's not taboo to fetch what is at risk of being left behind. Return, go, look, seek, and take. You'll also see that the symbol is that of a bird whose head is faced in the opposite direction of its body. This is emphasizing on the fact that even though the bird is advancing, it periodically makes it a point, okay? It makes it a point to examine or to return to its past, since this is the way or the only way to for one to have a better future. Now, what I mean by that, and that is why I chose this as my brand, um, you are going through typical times right now with COVID-19 and what have you. You must not uh, feel bad of what has happened in the past, but we look towards the future and we work hard, we'll get there. And also, your past is quite important for your future. Okay, so I'm going to start off with question 1 if you have a copy of the question paper. And question 1 is about ratios. It says that Miss Gusau needs the following ingredients to make 4 loaves of bread. I put these loaves of bread in inverted commas because they wrote breads and I didn't like that grammar. Okay, so the question is, you're supposed to express the ratio of yeast to sugar to salt. All right, so yeast, sugar, then salt. You have to be a bit careful with this ones in its simplest form. Now that is quite very straightforward. You write them in that order: yeast, sugar, salt. Don't put the units there. Now 5 is the highest common factor. You divide throughout by 5 and then you end up with 2 to 100 to 5. It's 1 mark. Correct answer only. The second part is how many kilograms, and you must be careful here because we are now talking about kilograms, okay, not grams. So there's something that you have to do. Would Ms. Gosau need to make 36 loaves of bread? Okay, so I divided into a few steps. So the very first thing is I converted 500 grams to a kilogram. Obviously, that is going to be 0.5. And then the second one, then obviously this is where I now do the work. And I said, now let me take the loaves, because I can treat them as equivalent fractions by comparing the loaves of bread over, the kilogram with the unknown, cross multiply. Bottom line, there's so many methods you can do this. You can use the ratio method, but you should get 4.5 kilogram as the answer there. The B part is in 2017, it is given that her total income from selling bread was 54,000 Namibian dollars. Now, I keep on telling my students, before you attempt to, start working through a question, always look at your mark allocation because you're going to get an idea as to sometimes the amount of work that will require for you to do this question. Then they keep on saying that in 2018, her total income was 12% more than what it was in 2017. So there are 2 ways you can do this. You can follow my step where I add the percentages because I know there's something more. And then I calculate 112% of 54,000. Remember, I am looking for an amount that is a little bit bigger because in 2018 the income is 12% more than it was in 2017. So I know that I'm looking for a big number. Alternatively, you can also do the second step where learners tend to go find what is 12% or 54,000 Namibian dollar, and that's 6,480. You add it, then you ultimately get to the same answer. Here's the problem with this method is that students normally end here and they tend to forget to add because we are looking for the income in 2018, not by how much, but the total income. So be very careful when you use this method. Then the second part of this part question says that the income of 54,000 that she had in 2017, this was 20% more than her total income in 2016. Again, we don't know what her income was in 2016. So we go to the past, all right? Since we don't know what it was in the past, be very careful. Look at the marker location. This is not normal percentages here already because we don't know the income in the previous year. And I emphasize the word previous. You know that you are dealing here most probably with reverse percentages. So I divided into a few steps. I compare the information. I like to do that, write down what I'm given so that I can pick a course of action. I added 120% here, the 20% to 100 to get 120 because I expect something. And look at my second step. So I then say the 54,000 is more because in 2016 it was less. So obviously that over some big amount, okay? And to have that, remember what I said, when you're dealing with fractions, the moment you are dealing with an improper fraction, you are expecting to get this value should be less, all right, when you compare them to like that. So cross multiply, you end up with 44,000 or 45,000 Namibian dollar. The reverse percentage part is here where learners let's go straight to. But here's the problem though. You might not have added and then put 20% here and then your answer will totally be wrong. You see what I did there with the word reverse? So please remember that that is what this question is all about. Mostly in the Namibian question papers, it's always about 3 marks. So be on the lookout for this particular question. Now, question 2 here deals with logarithms, but this is like a clever substitution, okay? So you have got log 2 is equal to h, and log 3 is equal to k. So you were supposed to express this h plus k as a logarithm of a single number. Now here's the thing about that a lot of learners do not understand that a number can be anything. Log, let's say 4, is a single number, all right? You can get something like this. This is a number. You punch it in your calculator. This is a value, okay? So be on the lookout that you do not think that log of something is not a number. It is a number, all right? So at the end of the day, we want it in terms of log of that single number, okay? We don't want the answer from the calculator as it is. So it's a clever way of substitution. So I have got everywhere with an h, I'm going to replace that with log 2. And everywhere where I have a k, I replace that with log 3. Now, when we're here now, we're not done. We use our log laws such that when we add logarithms of the same basis, we multiply the numbers, okay? And the final answer here is log 6. Again, I emphasize, do not work it out. We want it as a logarithm of a single number, okay? So that is what we're talking about here. Now, part B is a little bit different. It says that log 24, you're supposed to express log 24 in terms of h and k. It means your answers should contain h and k, all right? If we were saying and or, then it means either one or both. But here, your final answer should contain the h and k, all right? So my steps are, I first write 24 in prime factor form. When you do that, you arrive at log in brackets 2 cubed times 3. All right, I know that I can write them separately as log 2 cubed plus log 3. All right, that gives me the 3 in front. Remember your power law, that's 3 log 2 plus log 3. I'm nearly done. Now I don't want these log 2 and log 3 here, so I'm just going to replace that with h and k, and it's going to be 3 times h plus k. Ultimately, if you're here, you can also follow a different pattern where 2 cubed can be written as log 2 plus log 2 plus log 2 plus log 3. And when you add these like terms here, in terms of h, that gives you 3h, okay? So you do get the same answer. whatever method that you use there. Question 3 deals with the making something the subject of a formula. Here you're supposed to make y the subject of a formula. This question is quite intense. All right. You have got y, you have got a square root. So the first thing I do is I'm getting rid of that square root. And to get rid of that square root, the opposite of the root is square. So what you do on one side of an equation, you also do on the other side. The next step is I then cleverly just rewrite it for me, and I put p over 1 because I know somehow I can bring in some cross multiplication. Okay, the problem is that y is here in the numerator and here in the denominator. So when I do your cross multiplication, right, this is what I end up with. And I am going to multiply out the m because I need to collect my y. So the cross multiplication led to this. And I'm going to go up here now. Well, first then I multiply out, expand my plus mn. The reason why I did that is I somehow want to have all the terms containing y on one side, okay, so I can factorize it. And this is exactly what I'm talking about here. So I have mn that I left here, and I took my my, obviously it becomes a minus, and then I factorize that y, okay? So when I factorize that y, I can now get rid of this expression that is being multiplied with, okay, by simply dividing it. All right. Alternatively, there's another equivalent form where a student perhaps did not do as I was doing here by bringing this y, the my here, but rather they take this p square y to the left, and then they take the mn to the right. It is quite possible, and I just want to show you a little bit of a bouncing ball here. Okay, so if you were doing that, no problem, you can still factorize. Obviously this becomes now a minus, okay, and then this answer and this answer are exactly equivalent forms of each other, so you will still get the full marks for that. Question 4, the kinetic energy E joules of a given mass varies directly as the square of its velocity. V equals m/s, that is meters per second. Now, when the velocity is 5 meters per second, the kinetic energy is 150 joules. Now, here's the thing. You don't have to understand the whole science behind this question for you to know that you are dealing with variation, okay? And it's direct variation. Okay, so you can start off by, well, you can combine an equation. This is your standard form for direct variation. The E is directly, or it's proportional to V squared as the information you are being given. So a lot of times students, they put the square root here, so please make sure that you don't confuse the square with square root. Okay, so from here on, I just rewrite it as E equals to K, where K is the constant of variation. Okay, that is what we are supposed to find. That is why we are given this information here. All right, times V squared. We know that V is 5 for 5 squared, and then the energy that we are given is 150. So from here, you play around and you find the value of K. K is 6, but your work is not done now. So now that you have the constant of variation, you can go back to your equation, this part, and you just complete it as E equals to 6V squared. This is what we're looking for. Now that you have this particular equation, you can actually now answer any question. When they want something in terms of energy, they give you velocity. When they want something about velocity, they will give you energy. And then you just manipulate that equation in order to find what they are asking for. And you will see that in B part, for 1 mark, they say, what will the energy, kinetic energy, be when the velocity is 10? So you substitute V for 10, that should give you 600 joules. Very straightforward. If you mess up here and you are using indirect proportion or variation, then these mistakes will follow through. So please read your question carefully. Question 5 deals with limits of accuracy. The things that tells me it's that is I've got so many host of things. You see, I've underlined. They're giving me something here. They're saying it is corrected to a certain degree of accuracy. They give me another thing here, which is the speed that is corrected to something else. Can you see that? That tells me we have more or less some limits on our accuracy that we are dealing with here. So the distance between town A and B is 500 kilometers. So it could be 500 and something kilometers, 501, 502, not really 500 because it was given correct to one significant figure. Now here's the thing now, and this is what I'm going to put up. Maybe before I say that, there's something else that they say, find the least possible time. Now I know that I'm dealing with with limits of accuracy, rather. So least possible tells me I have to find the lower bound. Okay, and when I find lower bound, you have to be careful. Again, something else that comes into play is you are asked to calculate or to find your answer, the time. And the way we calculate time normally is we divide the distance by the speed. So when you are doing limits of accuracy, you must be careful. When you're looking for the lower bound, there is a little bit of a twist there. Okay, you will see as we go on. So my first step is I am looking at the first part where they say the 500 kilometer is given correct to one significant figure, and this is important. So when I look at the place value of the one significant figure, the most significant figure here is the 5. The place value of that 5 is 100 in the number system. I take the average of that 100, and this is the 50 that I'm going to add or subtract to that 500. Okay, and then I do the same with the 110 kilometers per hour. This is given correct to the nearest 10 kilometers per hour. Again, this could have been 120. The point is the 10th place is so happen to be 10, and that we divide 10 by 2 in order for us to know by what should I add and subtract when I look for upper bound or lower bound. But since we know it's least possible, so that indicates the lower bound, and this is what I did. I know that to find the lower bound, when you divide, you must take lower bound, divide it by the upper bound. Okay, so the lower bound would be 500 minus 50, remember? And then obviously 110 plus 5, because we have to divide that by the upper bound. And you get this decimal here. So please don't write 3.9. I gave it as 3.91 to 3 significant figures. But you can go ahead and write a full calculator display because we are not done yet. They want this question in hours. So I know it's 3 hours already. And then I take the other part, the decimal part, and I multiply that by 60, and I get 54.6 minutes. But I must give my answer correct to the nearest minute, and this is going to be 55. So the correct answer for this question is 3 hours and 55 minutes. When it seems that I'm so fast, you can always pause the video, go back and see what is it that you have done. Right, question 6 involves a little bit of equations that you're supposed to solve. And very interesting here, you solve for x. We want to find what is that value such that when we input it here and you multiply this answer by 6, you get 96, all right? So you can't really do trial and error here, okay? You have to do a little bit of manipulation. The first thing you do is you get rid of the 6. And you see what I did is they put the times there. Sometimes they just put the 2 raised to the x plus 1 in brackets and the 6 is there. And the biggest mistake is learners then multiply, and you shouldn't do that, okay? You get rid of this. The opposite of multiplication is division. And then you get an answer of 16. Now when you're here, no need to use logarithms because 16 can be written as a base of 2. 16 is 2 raised to the power of 4. Now when the bases are the same, you drop them because the indices are then equal. Okay, that's what it implies. From here you can find what plus 1 gives you 4. Now obviously that is going to be equal to 3. And that is how you find that answer. You can quickly punch it in there and you will realize you get that 96. Again, maybe in this part, if students were now bringing in logs, and this is how it's going to look like, okay? So when you take log both sides, obviously use the power law, you put this x plus 1, but it has to be in brackets, careful in front. Then you divide log 2 by log 16, use a calculator or change it to 16 to 2 raised to the power of 4, and bring that 4. Whatever you do, you see that I'm at exactly the same place here. I can now find the value of x. This one is a very straightforward question. You just have to find the solution to the inequality. X minus 3, something subtracted by 3 gives you 4. Okay, you can already do this by inspection. You know that it has to be 7. 7 minus 3 is greater than 4, right? Or is equal to, but this is not an equation. So I manipulate a little bit. I take that 3 and I add it. You see, I put it in red. And then I have my final answer is x is greater than 7. Part C of the same question is not an equation. It is an expression, an algebraic fractions that we are supposed to simplify. So first thing is first, we find the lowest common multiple, but before we do that, I tend to say a lot of times when you have expressions, whether they are the numerator or the denominator, put brackets. This one, the LCM is clear because you are subtracting. You just bring those brackets together. So the lowest common multiple will be x plus 2, x plus 3. This one does not have x plus 3. This one does not have x plus 2. So it's like kind of cross multiplication. So what you do here is you're going to simplify that numerator. And when you simplify that numerator, you get 3x plus 9 minus 2x. Now, be on the lookout. I put here minus 4 because a negative 2 times a positive 2 gives you negative here. Okay, a lot of times students tend to make mistakes. Be on the lookout for that. Sometimes you have a negative 2 here and a negative there, which will turn this into a plus. So when you clean up that numerator, you get x plus 5 all over the denominator. No need, please, to multiply out this denominator. This is the final answer. Question 7, the diagram that I'm bringing up here shows a parallelogram. Now, also it's not drawn to scale, so do not think that you can start measuring things. That's not how you solve this question. This is coordinate geometry. And as you can see, you've got point A, negative 1, comma, negative 3. You have point B, 4, comma, 0. You have point C, 2, comma, 6. This is X and Y coordinate, okay? And D is missing. The points D is missing the coordinates of that point. So later on, we'll be asked to find that. So the first things first is that they are saying you are supposed to find gradient of AB as well as the gradient of BC. Now it's very easy to find the gradient of lines if you know the points. 2 points, you can play around with the formula to get the gradients of the particular ones. So let us do line AB first. Okay, so the gradient normally is denoted or represented by M. Okay, the gradient of AB will be I take the exchange in Y divided by exchange in X, simply 2 Y values. So I go to my point A, my point B, and as you can see, I decided to start with this Y value, negative 3, and I subtract with that. And then because I started with this particular Y value of this point, I must now start also with the corresponding X value of that same point. Don't mix them around. So I must now find minus 1, minus 4. So when you clean that up, you get negative 3 over negative 5, which is 0.6, or 3 over 5. Ultimately, you can also swap the points. You know, someone can start at 0 minus negative 3. You just have to be careful there, okay? And then you start again at 4 minus negative 1. You will still end up at the same answer. So it does not really say start with point B or start with point A. It's just that when you start with point A and you start with the Y value of point A, then you must also do the X value of point A, and then you get your answers. So that is the gradient of line AB, and the gradient of the other line should be just as well straightforward. So you take the same two things, you have got, like I took 6 here, minus 0, that gives me 6, and then I take again the X value, which is 2, minus 4, that gives me negative 2, and if you divide 6 by negative 2, you get negative 3. Again, somebody could have swapped them around. Someone could have started here with 0, say 0 minus 6, okay, that's negative 6, and then 4 minus 2, and then you get, if you divide negative 6 by 2, you get negative 3. Now, you don't get marks for writing down the formulas, but it's always nice to write them down anyway so that you can know what it is that you are doing. Okay. Then B part says we're supposed to find the equations A, D, and CD. So I'm going to bring the diagram back. So we are supposed to find the equation of AD, that is this equation, and CD. All right. Then I brought in a little bit of something, the properties of a parallelogram that you need to know. You need to know that the two pairs of opposite sides are equal. Obviously, whatever BC is, it's equal there. That information is not relevant right now. What is relevant is parallel, okay? And parallel lines have equal gradients. So we know what the gradient was of AB. We also know the gradient of BC. So once we have those gradients, we can actually find the equation. So this is what I did. I said equation of AD, which is this one here, should equal the gradient of BC. The gradient of BC we calculated as -3. And I start to already write my equation. So the only things that are missing is to find my C. Now, because I have done that, I have now to decide to choose AD. You see, I can't choose a point here because I don't have it, so I must choose point A. And when I choose point A for y and for x, y being -3 and x being -1, and I sub them here, I will be able to calculate my C value. And once I have that, now I can actually complete the equation, which is y equals to -3x minus 6. I will do the same thing for CD. Okay, so CD again, the gradient of CD is the same as the gradient of AB, which we calculated before, remember? And then I substitute point C, and I managed to get my equation, which is y equals to 3 over 5x plus 24 over 5, which can also be written as this way, because the denominator is the same. Or then you multiply throughout by 5, and then you get this, also giving you the same answer. Now we're supposed to find the coordinates of point D. So let me bring the diagram back so we can see what is it that we have. So we are supposed to find point D. So I have written or typed down here the equations that we were supposed to find in red. So to find these points, this line, remember if you continue that line and you continue that line, they meet there. Alright? And when lines intersect and meet like this, it means at that point this line here is exactly equal to this line here because they share that point. And because that is the case, I can then take these two equations and I can equate them to one another. Okay, you also see which part that I use because it's easy for me to cross multiply. And when I do that, I eventually will end up to x equaling to -18. That means now, excuse me, x equals to -3. That means now I have the x value of this particular point. So in order for me now to so I know now the x value is -3. So I need to find the y value, okay? And in order to find the y value, I must take this x value, and I will have to substitute it, and I will substitute in this equation. I can even substitute in this one, but it's better for me to substitute in this equation in order to find what that value is. And you will see exactly what is it that I do here. I substitute, as you can see, I put it in red, and I get 3. So my y value here is going to be 3, as I indicate there. So I'm just going to bring it down. So that is how you find the coordinates of point D. A 3-mark question. Check it out again. It's quite a challenging one, but it's a very fun question. Now, question 8 asks you to simplify. Now, what I have done here is first I have factorized 2n minus 4. 2n minus 4, when you factorize it, it gives you 2, and in the brackets, n minus 2. It's factorized. And then this is the difference of two squares, and I hope you know how to factorize the difference of two squares, all right? When one bracket is a conjugate of the other. And because I'm dividing, then I change division to multiplication. And when you do that, you have to swap your fraction. It's like find the reciprocal of the fraction. And because it's multiplication, I can actually cancel out like terms, not like factors, as I have done there. And this is the answer that I get, and no need to multiply that 3 over, that is the final answer. 3 comes from this 3 times whatever you have left there. And then 1 times 2 gives us the 2, as I've indicated there. So this is also a very nice one. It's always in the examination. Make sure that you don't mess this up. The B part, this one is tricky. There are 2 ways you can do this. I have done both of the methods, all right? So first of all, They say you must leave your answer as a common fraction. Okay, so what I did is I have split. I know that this 32 over x, 32x here is, if I put it over 12x, because that's what it is, times, well, that stuff on its own, everything over 1 is just the same. The reason I did that is because 32 over 12x actually gives me, 32 over 12 gives me 8 over 3. Can you see that? 8 over 3. And then this 3 over 8 obviously is the one that is here now. Now, this part, when you are dividing, okay, and the x is for the numerator and the denominator, we can actually keep that x there, all right, in terms of our laws, power laws. But here's the thing now. I realize this is 8 over 3, and this one is 3 over 8. So I can cleverly make this 8 over 3. And if I do that, then I must bring in a negative, and you will see that is going to happen. So the moment I swap the bases here, all right, maybe I should do this. So the moment I swap the bases, okay, so that's terrible. The 8 going on top and the 3 staying there, you will realize that there is going to be a minus involved now, all right? And that minus tells me everything that I need to know, right? So that minus there, because you are basically swapping the base, as you can see now that my base is 8 over 3, so now this becomes a minus. So once I have that, now I have got a very interesting thing. I have got two bases that are multiplied. Can you see that the bases are the same? And if you multiply and the bases are the same, what do? You add the indices. Now, the problem is you're getting to a minus because if you are adding the indices, right? So if you are saying, well, x, then you have plus, minus, because that is a negative that is there, and then in the bracket you have x minus 1, all right? And this whole thing here was the base, right? The problem comes in here, not the problem, but what you need to be on the lookout for is that here is where the tricky part comes in. Can you see that you have got different signs, which ultimately will mean I have a minus there. So that is how I have that minus that I have there. Okay, and then also what you need to be on the lookout for is after doing all of this, and I do multiply out, I'll realize I get something else again that is very interesting. Is here. When you multiply this negative by this negative, you get a positive. And obviously negative 1 times x gives you negative x. So the x's effectively cancel. Can you see that? That leaves you with that 8 over 3 raised to the power of 1. Well, anything raised to the power of 1 is just equal to that. Can you see that? And you can leave your answer as a mixed number. And that does it for that question. Now I have done it as a different way, so you can have a look at that. Put the slide up. I've done it in a different way. I put the slide up here. Now, this is perhaps what you are very commonly used. Okay, so first of all, I know that there is a useful hint that when you work with indices and the bases are not prime, you can see this is 32 and this one is 8 and this one is 12. Obviously that one is a 3, it's a prime. Then it will be imperative for me to change those bases, okay, in prime factor form. So 32 is 2 raised to the power of 5, 8 that is here, that becomes 2 raised to the power of 3, and the 12 is 2 squared times 3. So if I have done that, you will realize that now I have 2 raised to the power of 5 with that x there, and I have 3 here. And now that whole x minus 1 is for the 3 as well as for the 8. Okay, so this is the 8. I still have this division. It comes from this division line here, right there. Can you see that? All right. And then here I have my 12. But my 12 is now 2 squared times 3. All right, with that x there. Step by step. And then you go on and you realize I'll take the 2's together. Now, since it's being divided here, you must be careful. All right, you just clean it up a bit for me. And when I do that and I divide and the bases are the same, I'm subtracting the indices. And when I do that, I'll eventually also, what I also have done is I have distributed this x for both of these according to the laws. So here is now a little bit of a small issue. You must be careful. That negative times 3x is negative 3x, but a negative times a negative gives you a positive. You see, I put it in red there. And then we still have that numerator there. And now here the 2x, 2 raised to the 2x times 3 raised to the x, I put them in green, all right, for you to know where they come from. It's here, and this is one's here. So when I do my numerator here, I clean up this, I get 2 raised to the power 2x plus 3, and I still have this here, and here I've got 2 raised to the 2x times 3. I showed a lot of steps there, but not really, that necessary. So when we work from here now, I have got this one here divided by that one here. Now because I'm dividing, and this is where you need to be a little bit on the lookout, okay? If I just take these two, because I'm dividing, and since I'm dividing, so effectively I have got to subtract the indices when you divide, because that is like 2 raised to that stuff there, okay? Then we divide, all right, I hope you can see my division, with 2 raised to the 2x. And when you do that, and the bases are the same, so now if we have the bases are the same here, and the bases are the same here, what do we do with the indices? Well, we subtract the indices. Can you see I showed that with red down here? Okay, so what I did is the ones in green, I want to show you where they come from. So that is the same concept that you do for the 3 raised to the power of x plus 1, or minus 1 rather, and also for that. That is what I did here. All right, and if I then continue to clean that up, you realize that we end up getting the following as a final answer. We then get, well, that is going to give us 2 to the power 2x plus 3 minus 2x. So the 2x is cancelled, leaving me with basically this 3 here. Okay, so you need to be a bit on the lookout. Now I have that 3 here because this 2x here and this 2x here, they cancel out each other. Again, the same happens here with this x and this x cancelling it out each other, leaving me with that 3 raised to the negative 1. Anything raised to a negative power means it comes under, right? So this is the final answer. So this answer is exactly the same as the previous one. So study it, go through it. I showed a lot of steps. Maybe you can show different ones as well. Question 9 is dealing with long division. All right, find the quotient and remainder when this function here is divided by 2x minus 1. So I've done it already for you here, so I hope you still remember how to deal with this particular question. All right, the first thing you do is you take 2x goes into 8x cubed, and that gives you 4x squared, very important. So I'm just going to show you one step. Then you take that 4x squared, you multiply by 2x, that gives you this 8x cubed. Then you take the 4x squared again, you multiply it with this negative 1, that gives you negative 4x squared. And I put brackets here because I'm supposed to subtract. It's long division. When you subtract that, those cancel. And here you must be careful. A negative minus negative, you say put them in red. There's going to be a plus here, right? So it's negative 10 plus 6. So just take your calculator, put negative 10 minus negative 4, just the coefficient of the x squared. All right? And then you bring the 7x down. And then you start the process all over, okay? Because you started with this term. Now you're going to start with this term. And then you're going to go there, all right? So now we say 2x goes into negative 6x squared, okay? So that is very important that you get it. So we say, for example, negative 6x squared, all right? This negative 6x squared that I have here. And I'm going to divide it, that negative 6x squared, I'm going to divide it by this 2x here again. So if I divide it by 2x, all right? Then you have 2 goes into negative 6, negative 3 times. And x squared give you this answer. This is the answer that you see all the way up here. Okay. Now, if you have that particular answer, then you go back again with your steps. All right. You have this particular answer. So now you go back again. You start your procedure all over. You take this negative 3. You multiply with that. And you get negative 6. Then you take this negative 3 and you multiply it with negative 1. Negative 3x times negative 1, that gives you positive 3x. Can you see that? And then you start the process all over again by subtracting. So if I subtract, then you will obviously realize that I'm going to get the following. I'm going to get this cancel out, and 7 here, x minus 3 gives you negative 7 minus 3, that gives you 7x minus 3x gives you 4x here. And then I bring down that 3 and I start again the process all over. If I have to write it out, I will. I take again the 4x here and I divide it again by that 2x. So that means that my side root will be now 4x here divided by the 2x. And obviously the x's cancel and 2 into 4 is 2. So this positive 2 is essentially what appears here now. Can you see that? And now, remember, you are now here. So then you take these 2, multiply by 2x, then you get 4x here. Then you take these 2, multiply by negative 1, and 2 times negative 1, that gives you negative 2. Then you just simply subtract. When you subtract, you will arrive at the following answer. You will realize that you are going to arrive at nothing else but 4x minus 4x is 0, and 3 minus negative 2 is the same as adding, and that gives you 5. And the final answer would be the quotient would be that whole stuff on top as it's there, 4x squared minus 3x plus 2, and obviously the remainder is 5. 4-mark question, you get a mark for each correct term and for that remainder. Question 10. The diagram shows a triangle ABC. So let me bring that triangle. Here's a triangle. As you can see, BC is x centimeter, and angle A, or this angle ACB, this angle here, C is 30 degrees, and BC or AC is the expression x plus 2. So they are saying you are told that the area of this triangle, this is 6 square centimeters. So we have to show that x is equal to 4. Now what you need to do in this particular question is you need to know your formula when you calculate the area of a non-90 degree triangle. So it's half times AB, where AB is your two sides that are flanking the angle, all right, times the sine of that particular angle is going to equal to the area. So if I punch that in, I have a half times x plus 2 times the sine of 30. Now the sine of 30 is nothing else but a half itself, all right? So I'm going to find first a half times a half, okay? That gives me a quarter. The x squared plus 2x comes from this x times x, and that x times 2. And now I will get rid of this 4. The opposite of 1 over 4 is 4. So I multiply here by 4, here by 4. That takes care of that. And when I do that, I get x squared plus 2x minus 24. So this quadratic factorizes to x plus 6, x minus 4. Everything, if you multiply equal to 0, then it implies either one or the other is equal to 0. So my first answer will be x is equal to negative 6. This answer can't be considered because you can't have a distance, a negative distance, okay? You put this here, it's not possible. So we're not going to consider this solution, but we're going to consider x squared equals to 4. Hence, we have proven that it is equal to 4. Question 11. Now, show that the x-coordinates of the points where the line y equals to 3x plus 1 crosses the curve. So what I did here is I took the curve and I took the line and I have them here. No, you don't have the software to deal with it, or they don't ask you to draw the graph. But as you can see that the line, it crosses the curve here at the point 1, 4. It also crosses the curve here at the point 2, 7. So the 1 and the 2 are the x points. Can you see that? The x points here, 1 and 2. All right. You are supposed to show that. So you do not have this. All right. The way we show that is where the line crosses with the curve at this particular point here and at this particular point here, the line and the curve are equal. So what we do is we take the curve and we take the line and we equate them to each other. That means x squared plus 3 should equal to this 3x plus 1. And once we have that, now we can clean up this equation, okay? When I clean up this equation, I'm going to eventually end up with a quadratic function. X squared minus 3x plus 2 equals to 0. And if I do my factorization, okay, you don't have to use the quadratic equation formula all the time. This factorizes, okay, to x minus 1 and x minus 2. If all of them equal to 0, then one or the other equals to 0. So my two solutions, as we were told, one answer x is equal to 1, or the other one x equals to 2. Again, you can see it from the diagram, and also you were given. So we have that. Now they will probably ask us to find the coordinates of the points of intersection. So simply, we know what the x values are. We just have to find now the y values. So when x is 1, substituting the linear one. I said linear because it is very straightforward getting the answer from the linear equation and not rather from that quadratic, okay? And you, everywhere where you have the x, you substitute it with that one, you get 4. So that point, one point is 1,4, and the other point is, when substituting 2 in, is 2,7. You can always go back, rewind, and have a look where the curve and the straight line meet. I've indicated also there. Then they ask you to find the gradient of a straight line joining the 2 points. This is very easy and straightforward because you've got 2 points. You can use the formula to find the gradient. Again, I started with 7 minus 4 for the values, the exchange in y. Then I took the exchange in x by simply saying 2 minus 1. Okay, that gives me a gradient of 3. Or you can use 4 minus 7 for the exchange in y divided by 1 minus 2. You're still going to end up with the same answer. Question 12. This one was a tricky question. A lot of students really struggled with this question, okay? And the only way that I could answer this question to make it a little bit easy for you is I created what is called a possibility space or possibility diagram. So you have got a spinner that is made from a regular hexagon, and the sectors here, you know, these sectors, they are numbered 1 to 6. Okay, the sectors look like, you know, triangles, equilateral triangles, and they are identical. So it tells you that they are identical. So when you spin this thing, it has a fair chance of landing either on the 1 or the 6 or the 2. Okay, so they spin this thing. Okay, and after spinning it, the arrow points to a number which is recorded. So it could be the 3, it could be the 2. But the thing is, they spun it twice. Okay, now this is where it becomes a bit tricky. So you have to find your answer in its simplest form. Very important. Find the probability that both numbers are the same. So I have brought in that space diagram. So what I did here is I said this is a 6-sided spinner here. All right, and I recorded my values here in red, and then also here another one because it's spun twice. Okay, so if you spin 1 plus 1, you add, you get 2. 1 plus 2, you get 3, and so on and so on. So like for 2 plus 2 gives you 4, and 3 plus 3. That is, I'm looking at the sum. If I take when it goes one time and another again, I add them up. I get this 36 grid right here, 6 by 6 grid, 36 squares, no, 6 by 6 grid. Now I can use this to solve the questions that are going to come forth, because they're saying, what is the probability that the numbers are the same? The probability that the numbers are the same, well, that is basically the same when you spin. You spin the thing once, you get a 1, you spin it again, you get another 1. Okay, so when you spin, you see I've indicated them in black here. So I get a 1 and a 1 again, it's the same number. I get a 2 and a 2 again, I get a 4, right? I get a 3, I spin, I get a 3, I spin, I get another 3. It's 6 if I add them all up. You see this space gives me that option. If I spin again, I get a 4, and I spin another 4 again. If I add them, I get 8. If I spin, I get a 5. One time I spin, I get another 5. Identical, I get a 10. The same here. So these ones here, 12, the 10, the 8, 6, the 4, and the 2, these possibilities, if I add them, this is what I'm getting. This is what we're looking for. So this is 36 values here, right? 36 values, 6 by 6, that is 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. So these are 36. So if you count the ones in black, you get 6. That's what I've done here. Over 36. And then the simplest form is 1 over 6. That's how you solve this particular question. Now they are saying you are supposed to find the probability that the sum of two numbers is a multiple of 7. All right. So my space diagram here possibility space diagram, it gives me, I have got 7s here. How did I get this 7 here? Is that 6 plus that 1 gives you 7. It's that 5 plus that 2 gives you 7. It's that 4 plus that 3 gives you 7, and so on and so on. So I have done this little, highlight this area here. So I have 1, 2, 3, 4, 5, 6 out of 36, because again, this is a 6 by 6 grid. Again, if you simplify it, you get 1 over 36 as an answer there. Part C of this question was quite a bit tricky. They say, what is the probability that at least one of the two numbers is a prime number? So what I did is, if I bring down my table again, okay, so for something to be a prime number, I took 1 minus what is not a prime number. That is mean everything, 36 out of 36. And then I take what is not a prime number. So I've listed here what is not a prime number. So I know that 1 is not a prime number. I know that 4 is not a prime number. I know that 6 is not a prime number. So I'm looking for that combination. 1 and what? 1 and 1 is 1 because it's not a prime. But not 1 and 2 because 2 is a prime. Can you see that? So I have 1 and 1. Then 1 and 4. Then 1 and 6. That's what I have done here. Then I go to the next one. I can't go to 2 because 2 will be prime. So even if I join 2 and 4, one of them will be prime. So I go all the way to 4. 4 and 1. Yeah, they are not prime. That's why I have them there. And 4 and 4 are not prime numbers. Okay, I have that pair there. And 4 and 6, they are not prime. And also the other thing would be now, if I choose 6, because I can't choose 5, because 5 is already prime. So if I pay it with anything, it's going to be 1 will at least be a prime. So 6 and 1, and 6 and 4, as you can see. And the last one is 6 and 6. So if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 of these out of 36 are not prime. So if I take the whole thing, 36 out of 36 minus 9, this is what I end up with, and that is what I get. That is how I answered this particular question for 2 marks. This one is straightforward. It says most of the learners got this one correct. It says find the probability that the product of two numbers is a multiple of 7. Well, there is no way. 1 times 1 won't give you 7. 1 times 3, if you multiply this by anything here, you won't get 7. The same if you multiply 2 by anything here, you won't get 7. I just want to see something quickly. If you add 2 prime numbers together, like 2 and 2, you get 4. All right, so that will not work. I was thinking of this particular thing here. All right, so coming back to this question here, the product of two numbers is a multiple of 7. So again, you can play around with this space diagram. You will see that you won't get. So if I choose 2 and I multiply it by 3, for example, okay, if I multiply those two, I'll get 6. And 6 is not a product of 7. It's not a multiple, excuse me, of 7, okay? If I multiply 3, this 3 here, by 4, well, that gives you 12. 12 is not a multiple of 7. And so you realize that none of them out of the 36 combinations there will give you multiple of 7. Then question 13, trigonometry again. This one was well answered. The diagram shows triangle ABC. As you can see, AB is 9 centimeters, AC is 5 centimeters. You got 2 sides flanked by an angle. You're supposed to find the third side. So in order to find the third side for 4 marks, you have to know your formula. That is the formula to calculate the third side using the cosine rule. So you don't get a mark for writing the formula, but if you have it, you punch it in on your calculator, you should not have a problem. The scientific calculator, non-programmable, of course, is going to give you 136.781829, and then you get rid by taking the square root. Okay, the square root of this particular answer, and that will be the answer that we look for in this particular question. For 4 marks, 11.7 centimeters correct to 3 significant figures. Question 14. Well, I have a table here. It shows the information about the number of pets that is owned by 24 learners. All right. So 24 learners, if you add all of this, 1 plus 2 plus 3 plus 5, the frequencies, if you add them all up, what do you think you're going to get? Okay, I can help you out. 7 plus 3 is 10. 10 plus 5 is 15. That's 18. All right. That's 20. That's 21. See if I get that correct again. 6, 11, 18, and 18 plus 6 is 24. So I added wrongly. So if you add your frequencies here, you get 24. How many times something occurs? But that's not the point. The point is we are supposed to find the mean number of pets. Mean, that means, there are at least one person who doesn't have a pet. There are at least two people who have got one pet each. And then there are three people who got two pet each, and so on and so on. So you multiply and add, multiply and add, multiply and add, and then you divide by the 24 number of learners. This is what you get, and your answer is 3.5. That is the mean number of pets. Then Andrew joins the group. So now we have another person who joins the group of 24 students or learners. When the information for Andrew is added to the table, so when we add Andrew now, then the mean changes. So we are now to find how many pets does Andrew, excuse me, I typed here Andres, but it's Andrew has now. So it's very simple. So I have 84 plus, we don't know the number of pets, right? But we know that I must add one because they are now one more extra person, and that is equal to the mean. So that gives me 84 plus x over 25. So from here you can cross multiply. And if you cross multiply, this is what you end up with. And then you simply subtract the 84. And now you know that Andrew has two pets. Right, this brings me to the end of this presentation. I hope that this presentation was worth your while, and I hope that you have learned a few things. Remember, it's best if you pause the video but do the question paper itself. You can get in touch with my Google channel where you are going to get copies in the extended class. That is the code you use to join my class. You are going to get scanned copies of the question papers of last year, paper 2 and paper 4. And also on the YouTube channel, I have explained paper 4. It's about an hour long, so use that time to check it out and pause it and share with your friends. Don't forget to subscribe and hit the like button. If you want to get in touch with me or anybody who struggles with any content, you can take a picture of the problem that you have. And then you can send a WhatsApp to me, all right? And then I will make a video of the problem and solve it for you. Sometimes I might even work it out and just take a picture and send it back to you without having to put it on YouTube. You can ultimately also email me, and then what on my 2 email addresses here for any particular information that you need. If you are a teacher, you need material, you can also do the same. You feel free to welcome to join my classes, and you will see that I have put a lot of information up there. I can add you as a teacher if you are a teacher, or I can add you as a student for you to access. I'm going to be putting up tests and a lot of material that I use. The objective here is to do question papers of 2019, what I did now, 2018, and 2017. I'm going to do the same for core. I'm going to put that up in the weekend, and I'm going to do the high level question papers as well. So by next week, the high level question papers of last year would also be, I will also make videos of those. Thank you very much.